Here we are at our example 5 from our 4.1 number 2 set of notes. We're asked to graph this particular quadratic in standard form. And we have our table of different values that we're looking for and helping us to do that. Now again, our A, B, and C, here they are getting identified. Please don't forget that B in this case would be including that negative value. So that's actually -6. Likewise, C is a -2 there. So just be mindful to include those negatives. Now, again, for the vertex, our x value is the opposite of b over 2 times a. And all we have to do is go ahead and plug in those values where they belong. So x equals the opposite of b in this case is -6 all over 2 times our a value here. In this case, we see that a is 2. Simplifying things further, we end up with the opposite of -6 is actually +6 on top, whereas on the bottom we get 4. And then simplifying, we get x equals 3 over 2. Now we'll go ahead and take that x value and plug it into our quadratic. And when we do that, we have y equals 2 times 3/2 squared minus 6 times 3/2 minus 2. Doing a little bit of distributing with that exponent, we have 2 times 9/4 minus 6 times 3/2 minus 2. And this will come out to be 18 over 4, which comes out to be 9 over 2 when you simplify it, when you multiply those two. Whereas this one will come out to be -18 over 2 minus 2. And then when we simplify this further, we should get -9 over 2, which is -4.5 minus 2, which comes out to be a y value there of -6.5. Because this again is pretty much saying 4.5 or 4.5 minus this is just 9. And that's how we get that -4.5. So for our vertex, looks like it comes out to be 3/2 or 1 1/2, comma, -6.5. So going ahead and plotting that vertex, 1 1/2 would be around there, and then -6.5. So 1, 2, 3, 4, 5, 6.5. So right about there in between. So that's like smack dab in the middle of that kind of square right there. Is where we should see our vertex. The axis of symmetry here, it is x equals that 1 1/2 value from, again, our vertex. So if we were to go ahead and draw a mirror of what that would look like, it should look something like that. Again, that's our axis of symmetry. And it is an axis. If you just accidentally put like the number 1 1/2 in this box, that would actually be marked off wrong. And the reason why that would be incorrect is because that would just be stating a number. We're talking about an axis of symmetry, and an axis is like a line. So that's why we need that x equals there. All right, that's probably one of the biggest common errors I see in that little box right there. So next up, we need to go ahead and figure out what is our y-intercept. So where is it crossing this axis? Well, every single time, as we've talked about, your x value there is 0. And all you have to do is plug that in. And we do know that because this is in standard form, this term's going to be 0, that term's going to be 0, so it's just your c value. So it would be 0, comma, -2. It's just that last number. 0, -2, located on the graph, is right there. And for the reflection point, since it's 1 1/2 units to the left of your mirror, we would have to go 1 1/2 units to the right of the mirror, put a little dot there. That is what it means to reflect it. And that point we can see is at 3 comma negative 2 that we just placed. So that's how you actually identify our reflection points. For the other point, we can go ahead and plug in a value that we think is going to work well for X. Now, when you're doing that process, again, I always encourage my guys to plug in a value that's really close to your vertex that you haven't yet used. So when I'm looking at my vertex, I notice that the X value is at 1 1/2, and I haven't yet used like 1 or 2 in terms of an X value in my little like table here. So I'm going to go ahead then and maybe use like the value 1. And so when I do that, I've got y equals 2 times, again, plugging 1 in there, squared minus 6 times 1 minus 2. And now I'm just going to go ahead and find out what does this y value come out to be. So y equals 2 times 1 squared is just 1. So now going ahead and multiplying my two different values together, I get 2 and negative 6. And then lastly, just adding and combining these together. So we get 2 minus 6 is negative 4, minus 2 again is negative 6. So when I plugged 1 in, I ended up with a y value of negative 6 there. Now going ahead and graphing that, 1, negative 6 would be located right there. And it's a little hard to see, but it is pretty much like a half of a unit from our mirror to the left side. So we're going to have to go a half of a unit to the right side. Plug in our little point there. So then we can identify that at 2 comma negative 6. And so that would be our reflection point. Now let's go ahead and draw the U. So we can go ahead and remove this mirroring stuff and go ahead and connect it. We should see a graph that does something like that. And so that would be our parabola. Now to help us out with domain and range, for parabolas, that for our domain, again the x's, that's always going to be between negative infinity and positive infinity. Whereas for the range, that's where you have to really pay attention and see what's possibly the minimum value or the maximum value, or what's the smallest y value that you can reach towards the highest, or vice versa. So because we have a u facing upwards like that, we create that minimum value there. And that minimum, again, we read ranges from bottom to top. That minimum value there is negative 6.5. And as we can see, it's going upwards towards positive infinity. Now in class we talked about the different things that you could and couldn't be. Infinity you can never quite reach, so that's why he'll always have a parenthesis. Whereas the negative 6.5, that's coming directly from the vertex, and you can actually be that point, and as a result, that would then have a bracket on them. But again, that is example 5 from our 4.1 number 2 set of notes.